In this video, I wanted to look at another way we can divide polynomials if we have a very specific set of conditions that are met. Okay, so if we have a polynomial of a degree 1 or higher, and we are going to divide it by another polynomial of the form x minus r, then we can use something called synthetic division. Okay, and this is a much faster, in my opinion, much easier form of polynomial division than using polynomial long division, but it can only be used um, in these exact conditions here, where you have a polynomial being divided by another polynomial of the form x minus r. You can't have anything in front of the 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 x here. It can't be a polynomial of degree higher than x. It has to be of the form x minus r, or something you can very easily turn into x minus r. Okay. So, again, this is another one of those where it's probably easier if I just go ahead and explain it as I do it, okay? So, the very first thing we're going to do, just like last time, we're going to um, use our little division sign here. But this time, instead of writing this whole polynomial, all we're going to do is write each of our coefficients, okay? And it's important that we get the coefficient for every degree on the way down. And we'll have an example here in a minute that I'll explain this a little further. But here we're going to put a 2, we'll have a negative 10, 4, 21, and negative 20. And then what we do is we put the value for r out front here. And since we're dividing by x minus 4, which is of the form x minus r, our r value is going to be 4. Okay? Then what we do is we make a little line here. Okay? And we're going to go ahead and bring down this first term. Okay, so we'll bring this 2 here, bring it down. And now what we're going to do is we're going to multiply 4 times 2. So 4 times 2 is 8. And we're going to put this here. Okay? And we're going to go ahead and add, our negative 10 to 8. So negative 10 plus 8 is negative 2. Okay? Then multiply 4 times negative 2. That's negative 8. So 4 plus negative 8, that's negative 4. 4 times negative 4 is negative 16. If we add these, we'll get a negative 5, or positive 5, I'm sorry. 21 minus 16 is positive 5. All right, so 4 times 5 is 20. So now we can add negative 20 and 20, which gives us 0. So this last bit here is our remainder. And then this first one here is the coefficient of our polynomial of a degree 1 lower than our initial polynomial. So the initial one was a polynomial of degree 4. So this will be a polynomial of degree 3. So these are all of our coefficients for our polynomial. So we'll have 2x to the third minus 2x squared minus 4x plus 5, and we have a remainder of 0. Okay? So again, these are your coefficients for your polynomial in descending order, which is 1 degree lower than your initial polynomial. Let's take a look at another one here. Here we have 3x to the fourth minus x to the third minus 11x squared plus 8x plus 7. And we're going to divide this by x plus 2. So again, let's go ahead and write everything, write our division sign here. And we're going to go ahead and write all of our coefficients down. So we'll have 3, we'll have negative 1, we'll have a negative 11, we'll have 8, and 7. And now this part here is very interesting, x plus 2. It's not quite in the form x minus r, but like we've seen in other examples, we can write this of the form x minus r. So you can think of this as x plus 2 is equal to x minus negative 2, okay? So that means we can rewrite x plus 2 as x minus negative 2, and x minus negative 2 now is of the form x minus r, so we can put that negative 2 out front over here. So instead of being 2, it'll be negative 2. Draw a line, and then we'll go ahead and bring down the 3. So we'll have negative 2 times 3, that's negative 6. Negative 6 plus negative 1 is negative 7. Negative 2 times negative 7 is 14. Negative 11 plus 14 is going to be positive 3. Negative 2 times 3 is negative 6. 8 plus negative 6 is 2. Negative 2 times 2 is negative 4. And so we'll have 7 plus negative 4. That's going to be positive 3. So our remainder is 3. Okay. And now these are the coefficients for a polynomial degree 1 lower than the initial one. So we initially had a polynomial of degree 4. So now we're going to have a polynomial of degree 3. So our answer is going to be 3x to the third minus 1x, or just minus x squared, minus 11x. Oh, I'm sorry, I'm reading this wrong. I was looking at our initial coefficients here. 3x to the third minus 7x squared plus 3x plus 2. And then we'll have plus 3 divided by x plus 2 here at the very end. Okay? So our remainder is 3, and we can also write that as 3 over x plus 2 at the end of this polynomial. So this would be the answer we have for using synthetic division. Okay, now let's take a look at this last one. And this was the example I wanted to look at a minute ago. Okay, so here we have negative 3x to the third plus 9x squared plus 7. And we're going to divide this by x minus 3. So here our R value is going to be 3. And now we can write down all of our coefficients. But here's where we need to be really careful. Okay, so we have a negative 3 out front. That's fine. So negative 3x to the third. Our next one is x squared. So we'll have a 9 here. And then we have just plus 7. So you'll notice we're missing a term with just x in it. Okay, we go from x to the third, x squared. We don't have an x, and then we have an x to the 0 or just 1 for this 7 here. Okay, so we have to make sure that we include something for that x term. So we're going to put a 0 here. And the reason for this is we can think of this polynomial, negative 3x to the third plus 9x squared plus 7. That's actually equal to negative 3x to the third plus 9x squared plus 0x plus 7. So this will be a polynomial written out fully in descending order. And that's how you have to write this here, okay? So we're going to use that. So then our next term will be 7. And we said our R value was 3. So now we're going to go ahead and bring down this negative 3. So we'll have 3 times negative 3 is negative 9. 9 plus negative 9 is 0. 3 times 0 is 0. Okay, 0 plus 0 is 0. Okay, and then 3 times 0 is 0. 7 plus 0 is 7. So we have a polynomial of degree 2, where these are our coefficients, which is going to be negative 3x squared plus 0x plus 0. And then we have plus 7 over x minus 3, since 7 is our remainder. Okay? Or we can go ahead and just eliminate these and write this as negative 3x squared plus 7 over x minus 3. So that's how you would write this, this new polynomial here.